Oh, the listener could well be pardoned for saying, all right, this is all well and good, so you've given me a good approximation, so what? Is there any consequence to this? It's a bit esoteric. Is it actually useful? And indeed it is. And here's where the utility of Poisson's approximation suddenly started becoming apparent. It took a long time. Poisson himself thought it was a curiosity. He dispensed with it in one page in his book, and he really didn't do very much with it. It took about 70 years after that for the first applications to start arriving. And today, I've given you a laundry list of possibilities ranging from the trivial and the absurd to the very rich and deep and portentous. For example, if you have a collection of people, what are the chances? What is the probability that, say, 3 of them are born on New Year's Day? We can think about being born on New Year's Day as tossing a coin whose success probability is 1 in 365. Each individual tosses their coin to get their birthday, and now you're asking, what's the probability of 3 successes? N, if let's say we have an assemblage of 500 or 1,000 people, is quite large. P is 1 over 365, it's very small. We are now in fertile ground for a Poisson approximation. Or perhaps slightly more frivolously, let's say one has a birthday, and one's loved ones makes a birthday cake, and because you're fond of raisins, they put in some raisins. But sadly, they didn't put enough raisins. Suppose you cut the cake into very many thin wedges. What are the chances that the wedge you get contains a raisin? Think of a raisin falling into a wedge as a rare event if there are few raisins and many wedges. Again, we have a promising ground for a Poisson approximation to a binomial. Misprints in a book. On a given page, there are a large number of words, and a word may occasionally be misspelt. There could be a typographical error. If the publisher is reputable and the quality of the book is good, one does not expect very many errors in the book. If that is the case, then each word is an error with a small chance. There are relatively few errors in the whole book. The chance of a word being an error is a rare event. We have a lot of words in the page, and again we have fertile ground for a Poisson approximation. On a slightly more serious level, manufacturing defects. Clearly, a manufacturer cannot tolerate a large number of defects, otherwise customers will flock away from him. So presumably, defects constitute rare events. What is the distribution of these rare events? Of course, defects in critical places could have very serious effects. So to analyze this, we need a proper probabilistic model, and again, a Poisson approximation gives us a good starting point. A key discovery of the late 19th century, the early 20th century, was the discovery of radioactive decay. What governs the behavior of elementary particles, and in, for example, a position where a radioactive element decays, giving up alpha and beta particles, what is the distribution of the number of particles that is observed? And again, we are in the province of rare events, if you're thinking of low levels of radioactivity. Similarly, looking at the number of photons emitted by a photon gun in a low light environment. And again, we are in this province. Accidents. What can one say about the frequency of accidents on a given stretch of highway? Again, presumably, accidents are rare. We're dealing with rare events, and we have a Poisson approximation. Queues and arrival processes. What governs arrivals of individuals to a queue for a movie, which is highly anticipated, to the opening of a new bookstore? I understand bookstores are quaint these days, but at one time people did go to bookstores. Arrivals of packets to an internet server. Now again, we're thinking of a setting where the events might not be rare anymore, but they seem to capture the flavor of what happens in a Poisson approximation. This turns out to have very rich and deep consequences in the theory of queues, in transportation, in telecommunication, and in astrophysics, in the distribution of stars and in the cosmos. Again, think of the formation of a star as a rare event in the vast immensity of space. So Poisson's observation, his curious approximation, turned out to have unexpected rich consequences. We'll now spend some time looking at some of these applications in greater depth to see how well this kind of modeling fits the reality.